What would you get? I got 3199.
No, that's for the half. Or half, sorry.
What would you get for
3,000.
How many questions is there on that? I don't think that seems 50.
Good morning, everybody. I hope your day has started out well. If you would please put your pencils down and pick up your colored pen, and let's see if we got a good start to my class. So let's start with number 1. What is the slope of the line? I've got student number 9, 15, and 2. Student number 9. Student number 15. Student number 2.
1/4.
So 3 of my students think it's 1/4. I hope the rest of them thought that as well. Number 2, what's the exponential function? What's the model? Student number 19, 14, and 3. Student number 19. Student number 19 is not here. Student number 14. Okay, and student number 3.
It's y equals a with the parentheses 1 minus r and then t.
Right, but I want the actual model from this scenario. So I was
Okay,
looking
I got
for
I got
y equals 4,600 times 0.982 to the t power.
I got that.
That's fine.
I just didn't want it, 'cause I thought
That's fine. You weren't sure what I was asking. I understand.
You said model, I thought.
When I ask for an exponential function to model this situation, that means you're taking the details of this scenario and using the model that we learned. So what does the population turn out to be in 2010? I got student 6, don't have student 6, student 4, student 11, and student 21. Student 4,
3,199.
student number 11,
3,100.
student number 21.
3,199.
So we got 3 students who got 3,199. Hopefully the rest of my students got 3,199. All right, so now the floor is open for questions on any of these. We'll start with Ethan, then Aaron, then Melinda. Okay, so how do we get 1.8% into a decimal? It's the same way you turn any other percent into a decimal. You're moving the decimal over 2 spaces. And if you have an empty space, you fill in a 0. So 1.8% as a decimal is really 0.018. So the model is y equals a times 1 minus r to the t power. So we have to take 1 and subtract 0.018. 1 minus 0.018. And that's how you get the 0.982. Okay? Aaron? Same question. Okay? Other questions? All right, well, I have a question. Give me a thumbs up if you got number 1 correct. Good. Gloria, how'd you do it? y2 minus y1 over x2 minus x1. I'm missing something over here. What goes right there? Angela? M. x1, y1, x2, y2. Compared to the incredibly complex material you've covered since then, this is not challenging for you anymore. At the time you learned it, it was incredibly challenging. So now at this point, it's just memory. Any questions about number one? Melinda, I think I skipped over you, and I apologize for that. Did you have a question on a different one?
No.
Okay, I apologize. I did not do that intentionally. Any questions? Concerns? Okay. So today, of course, you've titled the lesson 9-4. We have now had experience with 3 different types of models. The whole point of all of this is for you to be able to do research and come up to conclusions and then to be able to make predictions. That's the whole point of all of this. Because things in our world tend to follow some similar patterns. The real world rarely works perfectly. So what you have to get used to as you get older and older is how do you take what you've researched and fit it into one of the standard models, and then what can you do with it? And that's what we're going to be exploring today and next time. So we now are aware of linear, quadratic, and exponential models. So we're talking about the relationships between things. How can you best describe your data? That's the whole point. So, you are familiar with linear, quadratic, and exponential. So, here is a scenario that I've set up where it's supposed to be 4 different people of different ages and their heart rate while they were training or immediately after training, doing exercise. So the question is, what is the relationship, if any? So what I would like you to do is take a moment, get the table down, and I would like you to try and figure out, does this data fit a linear model, a quadratic model, an exponential model, or none of them? So I'm going to give you 2 minutes to see what you can figure out from the table. No, I'd like to try individually first. If you've already come to a conclusion, you can share with your teammates what you concluded and see if they came to the same conclusion. 3 choices: linear, exponential, linear, quadratic, exponential, or none of them. So, let's survey the class. Give me a thumbs up if you think this is linear. A lot of people think it's linear. Okay, put your thumbs down. So, now what do you think? Does that support your conclusion or dispute your conclusion? Does the graph support your conclusion? No? Crickets? Yeah, it seems to. Everyone in the room, I think, put their thumb up, and so you can tell that this seems to be following a linear trend. No, not the best. Approximately like that. So the point of doing this type of research is so that you can make predictions in between the points or outside of the points. So now you could say to yourself, oh, well, I've got this model set up. What will happen when someone is 60 years old and does this same exercise? I can expect their heart rate to be somewhere a little less than 140 beats per minute. Now we can make predictions. What happens when someone who's 35 does this same exercise? Now I can make predictions. Then you can take it a step further. Write an equation to match the model, to match the data, and then use that equation. You can find anything. Any age can be approximated. That's the real power. That's actually our ultimate goal. So I have a couple of more of these, but I want to show you what our ultimate goal is by the end of today. You're going to be writing a model, an algebraic model, for this scenario. And then you're going to use that model to predict another situation. That's our goal. So, it's a bit of a building process. So we've just started. So now, let's take a look at this one. I would like you to quickly make yourself a T-table. Jot down the data. I'm going to give you 2 minutes to see if you can come to a conclusion on what this is. So give me a thumbs up if you've come to a conclusion. Oh, just a few people. 1, 2, 3. Okay. Oh, a bunch. Okay, good. So give me a thumbs up if you think that this is linear. Thumbs up if you think it's quadratic. Thumbs up if you think it's exponential. A couple people. Give me a thumbs up if you just can't tell. A couple people changed their mind. Okay? So put your thumbs down. So what makes it difficult to tell? Something here does. Emily?
All the x values are like different.
Well, they're all different, yeah.
When you, like the difference between them are different.
Okay, so the differences are different. So it's not constant, and so that kind of throws us off. So now then let me do this. Now what do you think it is? Think about it for a moment. I'm going to ask you the same question. Give me a thumbs up if you think this is linear. Give me a thumbs up if you think it's quadratic. Give me a thumbs up if you think it's exponential. Give me a thumbs up if you still can't tell. Well, you should have put your thumb up at some point. Some of you did not. So this actually turns out to be a quadratic relationship. Because you can see, you should be able to see this. You should be able to see the parabolic nature of this. Like that. So one of the points of me using this example was that sometimes you can't tell until you actually graph something. In fact, what is most likely to happen when you do your own research and when you're in high school and you get to design your own research project is you're going to get data points all over the place. You're going to get data scattered like this. Oops, excuse me. And so you're going to then have to decide what would make the most sense. That's most likely what's going to happen. But the idea here was to try and put a situation out that you couldn't quite tell from the table, but to be quite honest, you should have been able to tell from the graph that this is quadratic. Do we understand? Maybe we're forgetting quadratic means parabola? Is that what we forgot? Or like what's the issue? Couldn't see it? You just couldn't tell? Weren't confident? Kiant?
Oh, didn't you say that when there's a parabola, don't the points mirror each other on each side?
They do, but we're talking about the real world.
Oh.
So it's not going to be perfect. And now, what if I draw in if I draw it in to the best of my ability? It does mirror. This point doesn't mirror that one, but every point has a mirror. That point has a mirror right here, and this point has a mirror right there. Or, that would be good, right about there. Every point does have a mirror. But you couldn't see them because they weren't mirrored in the table, and then the graph didn't come out perfectly. But yeah, this point will mirror over here, and that looks like it's about the vertex. Exactly, very good point. All right, so we did have one more, but I'm going to actually forgo it because I'm afraid that I'm not going to get to everything, and we have a lot to do. So we have one more, and it turns out to be exponential, so I had one of each. But I think we've done enough to see that you can sometimes tell when the table's presented, sometimes you need a graph, sometimes you need to go a little bit deeper. So now, putting it all together. This is everything that we've studied. Okay? So I got a copy printed for you and staplers can go back around and you guys can staple this into your notes. Because you're going to need to refer to this quite a bit because we're going to be using these different models over and over again. So This isn't everything you learned over the course of this year, but it's a lot of it. And so what you should be able to do is, to me, is work from the bottom to the top. And that's actually our goal, is to be able to start at the bottom here, have some data, figure out what relationship we see. You should be able to draw out the relationship, and then you need to be able to create an equation to then use to make predictions. So, data, analyze the data, graph the data, create an equation to model the data. That's what our goal is. Any questions before we jump in? All right. So first we're going to take a little more time to look for the patterns. And I'm going to modify the lesson a little bit as we go along. So look for a pattern and determine what kind of model it represents. So again, quick t-table. No rulers, quick t-table. As Emily had pointed out in one of our examples we saw a few minutes ago, it's really important to check the x values to see if there is some constant pattern happening. So you want to check here to make sure that's moving at the same rate, or at the same at a constant value. And you can tell instantly that it's just adding 1 and so on. Once that's established, you can then explore the other side. And so you start with addition and subtraction, and if none of that works, then you move to multiplication. So we'll start here. Let's start with addition. 4 plus what? 64. But then we've got 68 to 100. What's happening from 68 to 100? Ethan? Adding 32, right? Very good. And then what about from 100 to 100? What are we doing there, Aaron? Adding 0. And then what about from 100 to 68? What's happening there? Deja? Oh, now we're subtracting 32. So that's not constant. That's not constant, but now we need to check the second differences. So that's not linear. This is not a linear model, so it's not linear. And a linear would be y equals mx plus b. So we know that that's not going to work. So now we need to check quadratic. Check quadratic by doing the second differences. So now we'll check here, here, here. What's happening along my darker purple lines? What's happening there, Melinda? Subtract 32, subtract 32, and subtract 32. So what conclusion can we draw? Just 4 people can conclude something? Oh, 6 people? Oh, 8 people can. Sean? 10 people can.
The relationship is quadratic.
Yeah, it's quadratic. And so the model that would work for this would be y equals ax squared plus bx plus c. And it would take a little work to develop that equation, but we do know that it's quadratic. Anyone have any questions about that? Any concerns? So we've explored 3 different ones, including the first 2 that I put up. Any questions or observations, anything at all? So I am going to modify the lesson a little bit. I did have some more, and I did have a checkpoint, but we're not going to do it. So I want to now go to the big picture, the big point, which is writing an equation. How do we go from this to that? How do we go from this to that? That's our goal. Okay? So, now, use the data to figure out what model we should use. Then write a function that models the data. Then use the function. 3 things we're going to do. Figure out which type of model will work. Then write the function. Then use the function. So go ahead and get the data down quickly. So, analyze the table. We've just done it 3 times, so we should be pretty good at this point. If that's moving at a constant, which it is, now we can analyze what's happening on the y values on the range. So what's happening here? Anyone figured it out already? I got 5 people who figured it out. What do you think, Tatiana, and then Isabella? What did you think? Yeah, it's multiplying by 7. Anytime you see data, a set of data start out really small and then explode pretty quickly, there's a decent chance it's exponential. Although it could be quadratic because it could go really high and then come back down to be low again. So now we know it's which type of model. It's exponential. So what we're going to do now is write an exponential model for this scenario. So now everyone look at the little cheat sheet that I gave you. All the way at the top. So we have a model to go by. Y equals A times B to the x power. A had a special meaning and B had a special meaning. Anyone remember what A was? You should, because we did quite a bunch with it. What was A, Milan? Yeah, the start point. What was B? Two people remember? I'm becoming very discouraged. Ethan, what was B?
The rate.
Yeah. B was very good. B was the constant rate. B is this right here. So we have to fill in. The only thing that stays as a variable is x and y. Everything else has to be filled in. That's how you write a model. That's how you write a function. So we're going to fill in everything except for the x and the y. So y is going to stay y. Now A is the start point. Can we see the start point in the table? We can. Tristan, what is the start point? It is. The starting amount is how much do we have when time is just beginning? So it's 8. And we already know that the constant rate is 7. And so that's our model. But I want to pretend for a moment that we did not have this in the table. I want to pretend for a moment that it wasn't there. So just follow along with me so that I can teach you what you would do if it wasn't there. So we pretend, I know some of what I need, but I don't have A. I know that B is 7, but I don't have A. Anyone know how we can find it? It's a very simple way to find it. I know that it's there, but I'm pretending, what if it wasn't? Aaron?
You would divide by 7.
You can't divide by 7 because this x prohibits you from doing that. This exponent means you can't divide by 7. You could divide by 7 to the x power. However, we would still have an x, and that wouldn't really help us. Milan? You could, but we already did that. That's the 7. That doesn't get us the A. A is our starting point. What I'm saying is, what if this wasn't here? What if this was not there? What would we do? Okay, it's okay you can't see it. It's something you've done before. Pick an ordered pair and plug it in. This is x, and this is y. Pick an x and a y. Here we go. 1, 56. Ready? Watch this. Follow along with me. Y is 56. A is what we're looking for. X is 1. Now solve that. 7 to the first power is what number times 7? 8. So you use the data that you have to find the missing pieces of information. But we already knew that it was 8. I just wanted to make sure we understood that there's a way to find it even if it's not there. Okay? Any questions about that? Last piece. It says, use your function to predict how many people would have gotten the email after 1 week. Now, use the function. How do we use it? How do we use it? Okay, put your hands down. You use it. Go ahead, do it. You don't know how to do it? Ask your teammate. You should have no issue using it, though.
Did you get 6? 658?
Okay, how do you use it? Someone tell me what I need to do. I am a robot. I cannot do anything without simple instructions. Deja? Wow, you answered my next question without even... Are you a mutant superhero? You were able to read my mind? That's impressive. All right, y equals 8 times 7 to the 7th power because there's 7 days in a week. Now crank it out with the calculator. I have no idea what the answer is, so you guys have to help me. What does it come out to? What does it come out to, Christian?
6,580,340.
Kiana, did you get the same thing?
Yes, I did.
Read it to me again. 6,000,000.
588,344.
And this right here is a great illustration of the power of exponential functions and the power of technology. You can send an email to 8 people, ask them to do something with it, like send it to 7 people that they know, and in 1 week, 6.5 million people will have read the email. Anyone ever hear of the term, it's gone viral?
Yes.
Do you know why? Do you know how something goes viral? Exponential functions. That's what going viral means. Because what happens is that Isabella watches the super hilarious cat video, and then she tells 5 friends. She tells 1, 2, 3, 4, 5. So she multiplied the views times 5 one time. But then Mark tells 5 friends, and she tells 5 friends, and he tells 5 friends, and she tells 5 friends, and he tells 5 friends. Now we've multiplied by 5 2 times. And then it just keeps on going. And that's why not only do things go viral, but things go viral incredibly quickly. Also because our world has gone completely bonkers, but that's another story. So, any questions on how we analyzed the data? We analyzed it, figured out what kind of function would work, took the model, found the pieces that fit in, then used the model to get a result. Any questions? All right? We're doing one more together, and then you're going to be on your own. So, for this table, I would like you to write a horizontal table, so a quick little horizontal t-table. And usually with a horizontal table, the top row would be the inputs and the bottom row is the outputs, and that is the case here. So this is the x's and the y's. So our first question is, what type of function is this? Or is it none? So we need to analyze. What's going on with the inputs? Here, here, here. And then what's going on with the outputs? Here, here. Let's start with the inputs. Mark?
Oh, I'll say the y right.
Okay, we'll start with the x's. What's happening?
You're adding 10.
Beautiful. Plus 10, plus 10, plus 10. Go ahead, you're on a roll. So
For y, you're subtracting 50.
does it happen every time?
Yes.
Okay, so it's subtract 50, subtract 50, subtract 50. Okay, so what type of relationship is this? This is where all my students frantically wave their hands because they're experts now. Danielle? Yeah, it's linear. So when the first differences are constant, like we have here, it's linear. So now look at your cheat sheet if you need to, where I don't think you really need to. But look at your cheat sheet if you do need to, and you see that the model that's linear is y equals mx plus b, slope-intercept form. To write a function for a scenario, x and y stay, and you replace the other letters with the appropriate numbers. So we have to find m, and we have to find b. Any ideas? How can we find n? Let's start with n. How do we find it? Magic. She has magic powers over there. Maybe we can just do that. Everyone look back at your warm-up. Look back at your warm-up from today. Now tell me, how are we going to get m? Melinda? Well, that's slope-intercept form right there, so you're talking about something else. I'll help you. You meant to say slope formula.
Oh, yeah.
But, good, nice work. But we don't even need it. Someone tell me why we don't even need it. It's already half done for us. Ethan?
Because of the differences.
Yeah, it's already done for us. Slope is not just y2 minus y1 over x2 minus x1. It's also the change in the y's over the change in the x's. So the slope is the change in the y's over the change in the x's. So the slope is going to be negative 50 over 10. Simplify. So Sean, what's negative 50 over 10 come out to?
5 over 1.
Negative 5, very good.
Sorry.
So I know I put you on the spot. So y equals negative 5x plus b. We got to find b. B is the y-intercept. Anyone have any idea how we could find it? Aaron?
375.
Is it? All right. Well, the y-intercept is the value of y when x is 0. Is that the value of y when x is 0? Yeah, it is. So we know that it's plus 375. But let's pretend for a moment.
Oh.
Really? Let's pretend for a moment that it wasn't there. And we had to find it a different way. How could we find it? So we're going to pretend for a moment that we've got y equals negative 5x plus b, and we have to find this, and we can't use this. How can we find it? Let me give you a little tip. You already know how to do it. Emily?
Plug in some formula.
Yeah, go ahead, pick.
10 and 375.
Beautiful. Plug in an x and a y and crank it out. You're going to be able to do it with mental math. So she chose this ordered pair. So we've got 325 equals negative 5 times 10 plus b. Solve that equation. Mental math for my students in this room right now. Mental math. What does the answer come out to? What does b equal? Keanis?
375.
Comes out to 375. Negative 5 times 10 is negative 50. Add 50 to both sides, you get 375. So we know that we were right. Sometimes it will be in the table, sometimes it won't. You got to be aware of what to do if it's not in the table. I don't want you to come back on Monday, come to my care class and say, Mr. Gallant, I was able to get the slope, but I couldn't get the b. I don't know what to do. You can come, but I'd rather you say, well, I know how to do this. We explored this. Let me think about it. Or just think about logic. So now we're asked to use our function to predict the temperature after 1 hour. Go ahead. Find the temperature after 1 hour. Find the temperature after 1 hour. Go. You got 30 seconds. My really high-level students can do mental math again. So, my math superstars, what does it come out to? Tristan? Sean, you agree?
Yes.
With what? What did he say?
75.
That's true, he did. So it'll be 75 degrees Fahrenheit after an hour. Anyone have any concerns about how he used the function? So again, we analyzed, figured out which model will work, wrote the model specific for this scenario, and then used it. Any questions? So now no questions? Now the moment of truth. This is where we started, and this is where we're going to end. Write a function to model this, and then use it to predict how much water will be in the pool after 3 hours. So you've got 4 minutes on the clock. Any concerns or questions or guidance you need, please let me know and I will come around.
Wait, negative 2. Minus oh, wait, all right. Yeah, adding. Yeah, no, it's not. You're adding from 0 to 10. Why? What's the use? Oh, I didn't know.
All right. So I'm pretty impressed with the discussions and the effort. So let's see how this worked out. So I got student 17, 18, 15, 1, and 2. Student number 17, what'd you get? Okay, student number 18 is not here. Student number 15. Okay, oh, I'm sorry, I apologize. I'm looking for the function first. So tell me what your function was. Okay, tell me what it was. The equation that you wrote.
Y equals 1.5x plus 312.
Okay, student number 1.
Y equals 3 over 2x plus 177.
Okay, student number 2.
Y equals 3 over 2x plus 177.
Okay, so if you did 3 over 2x, that's fine. If you put 1.5, that's fine. Traditionally, we do not write slope in decimal or mixed number form, but in real world scenarios you can. And then unfortunately, if you didn't get that right, then you didn't get the second part right. So, Tristan, what was the amount? 582 gallons. So what I found after doing this lesson with a couple of classes is that the issue seems to revolve around the y-intercept, this plus 312. So Tristan, just because you happen to be one of the people I called on, how did you get the 312?
I plugged in the 10 and
So after you figured out the slope, so you used the slope formula, or you just figured out the differences and you just figured that out, and you ended up with y equals 1.5x plus b, and then you used this one right here, plugged in a 10, plugged in a 327, and cranked it out, and you got the 312. Great approach. Anyone do it differently?
I subtracted 15, 327.
Very good. How come you were able to do that?
Oh, because first difference in cost.
Okay. There's another reason why you're able to do that. Why is subtracting 15 going to work in this case? Well, if he subtracts 15, he's going that way, right? This was adding 15, adding 15, adding 15. If he subtracts 15, he's going that way. What's the other piece that has to happen for that to make sense? Aaron? Yeah, and where do we get to when we subtract 10? We get to 0. That was the key. If we subtract 10 and get to the 0, that's going to be the y-intercept, which ends up being 312. So it's all based on the fact that this is a pattern of adding 10. So if you go backwards, you subtract 10, and then you do the corresponding movement on this side. But it only works if it gets you to the 0. The y-intercept is the y value when x is 0. And that does work as well. Very good. Anyone do anything different? Okay, give me a thumbs up if you got, yes, go ahead, Mala.
I have a question. I got the function right, but I didn't get 565.
What did you get?
I got 365.
Okay. Because you plugged in a 3, right? This is 3 hours. And what is this? So what did you have to do with the 3? Well, if this is minutes, if x is minutes, yeah, you have to convert it to minutes. So, yeah, an understandable mistake. You're going to see that in your homework, so be aware of that. All right, we did quite well. Your homework is in the old workbook on page 112 to 113. You're doing numbers 6 through 15 and 18A, B, and C. You should be in algebration sections 7 and 8. I have put in grades all the way up through section 6. Your EOC was scheduled originally for May 4th and 5th. I'm now being told that it might be a week after that. I'm not sure. I have to get